Oi, boa tarde. Maddie, thanks so much for having us today.
Hello, thank you all for having me. I'm excited to be able to take a part.
Great. So let's start with your background. Our first question is, what was your motivation for starting to work with cybersecurity?
So I actually had never done anything with computers before I got to college.
Oh, sorry. Okay. We were out of sound, but I guess we're fine now. Sorry,
okay.
If you could just start over.
Okay. So I had never done anything with computers before I got to college, but I always knew if I was going to do computer science, I was interested in security, actually from a TV show. At least here in the US, there's this TV show called NCIS, which is a sort of police TV show. And on the show, there's a character, McGee. And for the team, he would solve all the mysteries and the crimes by hacking into every computer camera around the world, in 5 seconds. And so I was like, oh, that sounds cool. You break into stuff, solve puzzles, figure things out. So I really had no idea, but then I got into it, started taking computer science classes, and I really loved my lower level classes, like computer architecture, where you learn assembly, operating systems, compilers, and things like that. So it became a really natural progression for me to then get into reverse engineering and computer security.
I see. Wow, that's that was really nice. NCIS would never guess. So our next question is, could you talk a little bit about your experience working on Project Zero and the process to find zero-day vulnerabilities?
Yeah, so I joined Project Zero only about a year ago. Before that, I have had 2 other jobs previously. And I actually have a kind of new and different type of role for Project Zero. So I am not only doing vulnerability research into certain platforms or wherever expertise is, but I analyze and focus on studying zero-day exploits that are found in the wild. So the ones that are actually exploited as 0 days by bad actors to harm users. And so I study those, learn as much as we can from those exploits to then go and see if I can find other ones, often through variant analysis, meaning when you're looking for vulnerabilities, you often find more than one vulnerability at the time. Because if they've made the mistake in one place, they've often made it more than one. So if an attacker has used it and exploited that vulnerability, they've only had to use one of them most of the time. So it can make it that much harder for them to keep attacking if we can use that information and then we go and look for any of the other vulnerabilities that are out there that are similar to the one that's been exploited. Based on my background, I tend to do it mostly through manual code auditing, just reading either if source is available, such as for Android or Linux, or the binaries, such as for Windows. Other people on our team are specialists in fuzzing, where you write code that's going to automatically and continuously test something to try and find if there's a sort of overflow or bad parsing of a message, for example. But writing fuzzers has not been my area of expertise or where I go to most often. I tend to prefer the manual code auditing.
Oh, that's incredible. We have a question related to your peers, your work peers. So we want to know, what is the percentage of women that work with you, like in your working area?
So on Project Zero, there is one other woman. out of about 15, Natalie Silvanovich, or also known as Natashenka, who's done so much brilliant security researchers on Flash, on WebRTC and video conferencing softwares and protocols like we're doing right now. She's just amazing. iMessage vulnerabilities that came out late last year. So what that percentage is, 2 out of 15 for the current team. On Android security, it was pretty similar. I was often the only woman in the room, especially in sort of the engineering roles, and same at my job previously too. That, you know, it's, yeah.
Yeah, that's a little low, but let's hope that's gonna change soon, right?
Yeah, and just we gotta keep, I know there are women who are more senior and more experienced than me who have reached back to help me and give me guidance and open doors for me. And so the goal is to just do that for the women that are coming up behind us too, is reach that hand back, and hopefully more and more women stay in the industry and keep working.
Yeah, I guess that's essential. Now I have a question from Alex, who's a member of a cybersecurity extracurricular group we have in our college. Yeah, they have a group focused on reverse engineering specifically, and they sent a bunch of questions. They're really excited that you're here. So that's from Alex. He asked, what would you recommend to a college student wishing to work on the cybersecurity field? And what about reverse engineering specifically?
So asking about cybersecurity as a whole is really hard because there's so many different areas. It's actually a very broad field. Like what I do on a day-to-day basis is very different than those who are working to, for example, secure an enterprise like Google, or who are trying to build solutions for something like Android. They're, you know, writing more code while I'm breaking code, as well as, you know, we need program managers and leaders and technical writers. So there's a lot of different areas. But if we narrow that down to reverse engineering, the things that I always suggest is, one, learn C and get comfortable writing code in C. And the reason is that when you look at assembly and binary, you don't have all those types that you might expect for variables in higher languages like integer or long or struct or object string. You just have a series of bytes, and C is the closest we can get into in a higher level language to understand how all of those other different types we use in higher source code translate to memory. So learning how to program in C is hard. Pointers are hard, but once you grasp pointers, reverse engineering is going to be much easier. Then also taking a computer architecture class. So understanding how the fundamentals of how you get from assembly up to those higher level source codes and back down is very helpful. There's a lot of different ways to apply reverse engineering skills because it's really a technique you're doing. It's not an exact problem you're trying to solve. So for example, I've used reverse engineering skills on hardware and embedded devices, as well as for malware on the Android security team, where I was looking at all of these Android apps, trying to figure out which of these are harmful versus which are not. And now here on Project Zero, I'm using those techniques to, one, understand zero-day exploits, but also then understand code bases to find vulnerabilities. So for that, you know, C, your computer architecture class, just looking at assembly, you don't need to know them all. So just choose one, or whichever one your computer architecture class is teaching, whether it's MIPS, x86, ARM. Generally, once you understand one, it's pretty easy to switch between the different ones. So just get the grasp of a single. If you don't have a computer architecture class, there's a free one online called NAND to Tetris, and that's a great one. It will take you all the way through and sort of makes it game as well. And then just start looking at assembly. There's really not a lot of tips and tricks, is that you get better at it by looking at more, because you start to see the patterns. So the first ever reverse engineering project I did at my first job, I was given, you know, this is your job, is to find something, and they gave me more details, but I'm looking for something that has to do with its communication protocols. And I was like, okay, here's a function. I think it's important. I'm going to dive into it and figure out what it does. And I spent all this time going, annotating every single line of code, like R4 now equals R2 plus 36, and went every line of assembly. And by the end, I got to it and found it is printf. But the thing was, I spent all this time reverse engineering printf, but I never had to do it again because I know exactly what printf looks like in assembly now. And so, all of those times spent just make you better later on. And so you just have to keep doing it. There's not a secret thing. Reverse engineering, staring at code or staring at hardware constantly until you see the pattern.
That means a lot of bravery. But I'm really glad that we have like 2 years of studying only C at our computer science course. I'm really glad for that now.
Oh, that's wonderful. Yeah, and both for malware and for vulnerability research, operating systems is super helpful, as well as if you have a compilers class. Because once you have and understand those foundations, you can then apply it to whichever operating systems, whichever languages you want to work on.
Mm-hmm. Maddie, can you recommend any books for people who want to start practicing reverse engineering on Android apps? And also, do you know any good YouTube channels about this?
Well, I have an Android workshop about reverse engineering Android apps. It's maddiestone.github.io/Android AppRE. So and it has YouTube videos that go along with it and exercises. So yeah, that's weird to self-promote.
That's really nice.
But so I really try to cover everything you need to know about reverse engineering Android apps. Books-wise, I don't know of any specifically that I've used or I've recommended, but there are some. Maldroid on Twitter, he tries to add a lot of information and presents a lot on Android app reverse engineering. He's also a Google employee and someone I worked with previously when I was on the Android team. And I'm going to blank and not remember them, but there's a few other Twitter folks who focus all on Android app reversing. And so through their presentations, through their blog posts, I think is one of the best ways to learn how to do it. And again, it's just doing it, is just figuring it out, seeing when people write stuff up, trying to follow the steps by yourself so you start to understand what they were seeing. So then you see it too.
Pretty much everything regarding computers is you got to do it to learn how to do it right. Do you have some examples of what not to do regarding mobile devices?
What's the context? I mean, I would say don't drop it in the toilet.
Well, that was Iran's question, but I'm gonna guess regarding security of apps.
If you have an Android device, do not download apps except from the Google Play Store. That is a huge one. Because untrusted apps or setting the permissions such that they can be downloaded means that if you get any malicious or questionable, sketchy app on your device, they can then download apps from other places, which are likely malware. So that's one of the big things to keep your device protected. Always have a PIN and password on it. That's a pretty basic one. What else? What else do I do with my phone? Password managers are great, whether it's on a mobile device or on your laptop. But seeing as we all access so many websites and apps from our phones, that's always important. That's all I can think of, I think, off the top of my head.
I think that's enough. Thanks. Now I have some questions about people wanting to get into the security area. I have two actually that are very similar, so I guess I'm just gonna name them. Okay. So the first one is from Victor. He asked, which recommendations would you give to developers? Oh no, actually I missed that, but okay, so it's gonna be only one question now. which recommendations would you give to developers who are not in the security area, but want to build good developing habits?
So there's a great book about understanding vulnerabilities and the mistakes that developers can often make and that lead to these vulnerabilities. So that book is called The Art of Software Security Assessment. And whether you are a developer wanting to code defensively and securely, or if you're someone that wants to get into vulnerability research, that's kind of like the Bible. That is the best book out there for that type of thing.
That's really nice. Now I'm going to ask the questions I was going to ask before. What would be a viable path for those who already have a completely different academic background and are interested in cybersecurity? And the other question that was similar to that one was, if you were to start studying information security today, what would be your first steps?
So I think it depends on what that background is previously, because there's a lot of other skill sets outside of cybersecurity that the skills still apply, and you're now just putting them to apply to InfoSec. It's also, what do you want to do? We're all always better at a job or a role or a project when we enjoy it and we're passionate about it. So with those two caveats, me, if I was starting today, I would probably get involved in the CTFs at my college or universities, because I think it's a great way to network, but it's also a way to start testing your skills and building them in a fun environment where there's really no risks. Because I think getting all those hands-on experiences as CTFs keep getting tougher and tougher is a way to build lots of skills. If I didn't already know, I would probably pay attention more in my C class, because I think early in my career that definitely kind of bit me, that I didn't always pay the closest attention to classes like C and operating systems, because I was like, who actually uses this stuff? It's just talking about, old historical knowledge. And now I see, oh, yeah, that's why I needed to have it. I also would look at hardware. In my first job, I had no background in hardware, but sort of fell into it and started doing stuff. And I think it's a really overlooked area. There's some people working on hardware security and the impact of CPUs and different types of chips, as well as just how do we build all these CPUs put together. But I think it's an area for a lot of growth too. So I would definitely try to take some classes about hardware or CPUs, because I think that's where everyone's going to need the help, and there's not enough people who are focused on it yet. Basically, if you are coming from a different background but are interested in security, then there's spots for you. Your skills that you already have are going to be useful and needed. It's just matching up what are the skills that you have, what do you want to do, and what roles exist. I can promise you there is some, but it's going to be very particular to you. So yeah, it's you might come from a theater background and can apply some of that art and that creativity, and you really love to solve puzzles. That's going to be great. Or you can come from, I don't know, a history, and you can use that writing and those communication skills to help advocate for the security changes that need to happen. Yeah, so that's sort of a very broad answer without knowing more specifics.
I think it's terrific to know that the cybersecurity area has room for everybody. Now, do you have any certifications?
I do not. So I did one internship before my senior year of college, and that internship had all of us go through the CEH certified ethical. Wait, no, not that one. Security Plus. That was it. I don't know why I thought it was CEH. So I got that certification just by going through that internship, which is now expired many years ago, and I've never re-upped it. That being said, I don't know that I was ever asked anything about it in any interviews. But that is something that is going to very much depend on where you're trying to interview, what types of roles you're looking for. Yeah, so I personally don't have any.
I think that's great to hear, because certifications are really expensive, and in Brazil they're like 5 times more expensive.
Yeah, and I mean, I definitely, when I was graduating college, I did not have any extra money to spare. So it was, and while I was in college, you know, I was working to just keep paying for my rented apartment. So yeah, I only got it because someone else paid for it.
That's great. I think we're gonna go to our last question, because we're running out of time, right? Which is too bad, because this one's really interesting. How do you and your team prioritize the incoming malware to sift through and analyze it? And how do you find the scopes you use?
The scopes?
Yeah.
Okay, I can try and answer the first half. I'm not really
Okay.
sure what's meant by scopes, so maybe that person can clarify. So on Project Zero, we are not focused on malware. But on Android security, we were, because I was a part of the Google Play Protect part of the team, which is responsible for going through all the apps on the Google Play Store, as well as many apps as possible that are just floating around the Android ecosystem and not a part of the Google Play Store. And so we had a lot of prioritization for, there were many more software engineers on that team than there were security or reverse engineers, because the goal is that a reverse engineer should only reverse the thing once, and then we should be able to build automated signals and have computers be able to determine it and things similar from there on out, because otherwise you will never be able to reverse engineer everything. So the priorities were based on a lot of different types of signals that were built from input from the security engineers to software engineers that were building giant, very large, very robust systems that would prioritize different things. After that, the way I as an individual would start to prioritize, where do I spend more of my time if I can only do one deep dive investigation and then have to do quick reviews of everything else, is one, you sort of get a feeling for the complexity. Does it really look like they're trying to hide stuff and are using lots of advanced techniques? How many different samples are out there that are similar to this, in the sense that if one of them's malware, that means then you have thousands of malware rather than just this one oddball or outlier. But this is really where security gets to be both art and science. There's no correct formula to decide. It's where the more you do it, you start to build this intuition and this gut and start to figure out, okay, I might not have this formula, but I know that this is something I really should prioritize looking at. And that just comes from the experience of just doing it.
We have the explanation about the scopes. So Lucas said, scope as in when to end the analysis and when to say, okay, this threshold is not worth the time invested in it.
Ooh, that's a tough question, and such an important question, because we never have enough time to look at every line of code, even though those of us who are reverse engineers want to understand every single line of code. And that comes into the context. Are you on a team like I was for Google Play Protect, where there are literally thousands of apps that need to be looked over every day? So each team member has 100 plus they have to get through. Or are you a research team where you have to look at the most interesting and can deep dive for weeks on into a single, malware sampler family? So you have to first take into that context. And again, scope really comes into that intuition of you start to develop when the feelings of, oh, this looks sketchy, but it was just bad coding. It's not actually doing anything that meets our bar for malware, versus something's off. I still haven't solved this puzzle, which tells me I need to keep digging. So that's an important part. There's sort of the same issue in vulnerability research of you can keep looking, but if a vulnerability doesn't exist, you're never going to find it. Despite how long you put into it. So you also have to continue reevaluating. What was my goal? How much time has I put into this? And is the next step I want to take worth or have a good enough potential return on investment? Or even if I find this thing after putting in this much time, it really wasn't worth it. And so those will change probably with each project you work on too.
We have time for one more question. So what are your thoughts on the de-Googled OSS, as in the /e/project? Something about Android without Google. Do you know anything about that? You don't look like you do.
Okay. I don't know anything specifically about that project. I go into the Android ecosystem in my Black Hat talk from 2018 explaining Google approved Android, authorized Android versus open source Android. The one thing about Google Android is that the Android security team works and vets OEM devices that are going to have the Google approved label for different security features, such as, they have to be providing patch updates this often and for this many years. You can't have malware pre-installed on your device, and that gets fed in different things like that. Otherwise, it's an open source code base, and it sort of depends how much do you trust who's building that code from a security standpoint, and do you trust that they'll be giving you updates and holding all of their app developers to a standard to ensure, you're not going to be harmed and different things like that. But I don't know specifically about that project.
That's okay. Thanks for answering anyway. So I guess our time's up. Thank you, Maddie, so much for being here today and answering all our questions. Thank you so much.
Thank y'all so much. This was wonderful. COVID and the pandemic is not great, but one of the positives is I get to be here with y'all because we're all virtual, so we don't have to be here in the same place. So thank you for having me.